So today we're going to talk about the naive Bayes classifier. And this is an interesting classifier because it has a few unique properties. It is very fast, so it doesn't require a lot of iterating through steps. It's done in a single step, and it also doesn't require very much training data to be very effective. And when you think about other classifiers, you think about a neural net. Neural nets generally can be slow, especially if they have a lot of hidden layers. And they also require a lot of training data to perform well at all. So this is very powerful when you think that it's all done at once. The calculations are done all at the same time in linear time, and it doesn't require very many training samples. So it does have a limitation, though, that it requires the features are independent. It has a very strong assumption of independence. So let's read this. What does this mean here? This is saying the probability of A occurring on the condition, that's what this is, on the condition that B has occurred. So this is equal to the probability of B occurring on the condition that A has occurred times the probability that A has occurred over the probability that B has occurred. So maybe you're looking at these A's and B's and conditions and thinking, oh man, this is a bit tricky to visualize, but let's just look at a case right now and we'll break it down into a very simple case that I think you'll be able to visualize. Let's say we have a coin flip and we flip this coin 2 times. And let's list our combinations, what that looks like. We have heads and heads as a possible combination, heads and tails, tails and heads, and tails and tails. Right? Those are our 4 different combinations. So let's define A and B so we can plug some numbers into this formula. Let's say that A is, on the first roll, we roll A heads. And let's call B on the second, I keep saying roll, but it's a flip, isn't it? On the second flip, it is a tails. So if we were going to plug in these numbers, what is this first term asking for? It's saying the probability of B occurring on the condition that A has occurred. Well, what's that condition again? The condition is that on the first roll, it's a heads. On the first flip, it's a heads. So that's satisfied here. Oh boy. Satisfied here, and it's satisfied here. B on the condition that A has occurred. So what's B? B is on the second flip, tails. And that's satisfied there. So there's 2 combinations that satisfy the condition and 1 combination that satisfies the outcome. So we can say that there's a 50% chance of B occurring on the condition of A. That's what we say. And then we're going to multiply that by the probability of A occurring. Well, A is just on the first flip, heads occurring. And this is where sometimes it can get confusing what this P of A is and P of A on the condition of B. Well, we have to think about every combination. So when we factor in every combination, we have 4 combinations and 2 are satisfied within those 4 combinations because A is heads being flipped on the first flip. So that's 50% because we look at the 2 that satisfy within the 4 combinations. All right, and now that is all over the probability of B occurring. And that's going to look similar to our probability of A. We're going to have on the second flip, we're going to have a tails, and that's satisfied here and here. And again, how many combinations are there? Well, there's 4 combinations. So that means out of the 4 combinations, we have 2 that satisfy, and that is a 50% chance probability, or 50% chance. So we plugged in our numbers, and then let's see what the outcome is, and we'll check our answer. So it's 0.5 times 0.5, and that's 1/4 divided by 0.5, and that itself is 0.5. These are kind of silly numbers, but I want you to see that this algorithm holds up in a very simple case. And it's important to distill the essence of the classifier so that when we move into many variables, we know what to do. We have some kind of intuition about what these different variable means and what we can expect. So let's check our answer. It says that it's a 50% chance that A will occur on the condition of B. So on the condition of B, that's on the second flip, it's a tails. All right, so this is our condition B. And the probability that A has occurred, which is the first flip being a heads. So we have two combinations of our condition, and we have one case where B is satisfied, and that is in fact 50%. So this is correct. We have correctly predicted what the probability of A is on the condition of B.